Hello, everyone, and welcome to the fifth video on the standard normal distribution, where we talk about other examples that use the concept of the areas of the normal curve. In the previous video, we made use of the z-table in order to help us find certain areas under the normal curve by making use of z-scores or standard scores. But in this video, we would be able to discover that certain applications that are available in the internet will allow us to find the answers much faster without having the need to make use of a Z table. However, just a way to emphasize that there is still a need for you to understand the Z table. Certain tests that you may take in the future may not necessarily allow you to make use of online calculators such as the one we will be presenting. So it would always come in handy whenever you know how to make use of the Z table, whenever you have to take an actual test that will rely on the manual device. All right. So let's take a look at several other examples. Um, this time we're going to work with a different situation. So suppose that when purchasing soda from a store, you notice that some bottles don't seem to have the same amount as others. So some seem to have less, some seem to have more compared to others. Suppose that the machine in a soda factory fills the bottle with a mean volume of 1.98 liters, when in fact its target volume is 2 liters. And the standard deviation of the volume of the liquid inside these bottles based on the um, factory or the records of the factory is 0.03 liters. What we're asked to do is find the proportion of these supposedly 2-liter soda bottles that are underfilled. All right. So what the app that we're going to use here is prepared by David Lane, and you should be able to find the link to the direct link to this online application via the description box. However, if you want to enter the link manually, this is the link, and you should be able to see it here at the bottom of the page. So let's work with this example over here. But some of the things that you need to take note of is if you're using this application for the first time, here are some useful instructions on the right side of the page. So specify the mean and the standard deviation of the problem that you're working with. Indicate whether you want to find the area above a certain value, below a certain value, between two values or outside two values, and then indicate what those values are. So what we would indicate here are the actual observed values and not, take note, it's not the z-score. We don't need to convert the given scores into their corresponding z-scores anymore. However, if the given values are in z-scores, then the mean and the standard deviation would be equal to 1, and we would still be able to make use of this online application. And finally, once all of the relevant information has been entered, we just need to hit tab, return, or recalculate. The recalculate button, and the area will be shaded in this, and the size of the area will be shown at the bottom. So we would both be able to see an illustration of whatever area it is that we are interested in, together with an actual value of the area or the probability over here at the bottom. So let's try that with our problem. Based on the given, we know that the mean volume is 1.98 and the standard deviation is 0.03. So that's what we're going to enter here. And since we're interested in the proportion of the production of the factory that's supposedly underfilled, and these what their target is 2 liters, so we need to look for the area below 2 liters. So let me just pick below, and then let me enter 2 here. So you don't need to be bothered with the other values that you see over here. It wouldn't really matter to the final answer that we would be able to obtain. So just disregard the 1.96s that you see here. But if it distracts you, you can easily just change all of them to 0, perhaps, or maybe just get rid of those values, right? Which is what I am doing now. Okay, and then when we press recalculate, but it actually already did when I entered 2 over here. we should be able to see a visualization of the area we're interested in and the percentage. So according to the calculator, this area covers 74.75% of the area under the normal curve. And what it means in the context of our problem is that 74.75%, in fact, of the bottles are underfilled or below 2 liters. So if you think about it, the factory should be concerned because 74.75% is quite a huge number. Although you can argue that perhaps 1.99, 1.98, the difference of point out of a hundred of a liter or a couple of hundredth of a liter is not too significant to be noticed by consumers, and it's not going to affect um, the product, right? So yeah, let's take a look at a second example. So this time we are asked what the proportion of the soda bottles would have a volume that's above 2.08, given the same data that we have. So using the same online calculator, we enter the mean again, which is 1.98. The standard deviation is 0.03. And since we're interested with the proportion that's um, above 2.08, so let me just select above and then enter the value 2.08 and then press enter. And notice that you should not be surprised if you see that the illustration here does not show any shaded region. And that's uh, because 2.08 is quite a large value in comparison to the 1.98, and we reference to the standard deviation of 0.03. So in fact, if you take a look at the values that we see over here, 2.07 corresponds to three standard deviations away from the mean, and 2.08 is way beyond that. It's not way beyond, a little beyond that. Therefore, the region that we should see shaded here is some portion of this region over here, and it's not really very obvious when you take a look at it and in this far from the screen. However, when we compare it with the area or the probability, and we see that it's 0.0004, it makes more sense. So we're seeing 0.04% of the total area under the normal curve. Translating that into the context of our example, we say that 0.04% of the bottles have a volume that's above or greater than 2.08 liters. Okay, let's proceed with example number 3. Suppose that the bottles that contain more than 2.06 liters of soda and those that contain less than 1.9 liters will need to be discarded because they're either beyond the acceptable standard and or below it. How many per 5,000 bottles will have to be discarded from those that are produced by the factory? So this is a two-tiered question. We need to find the proportion first, and then make use of the data that's 5,000% of the bottles are produced, and how many of those 5,000 will have to be discarded from the market. All right. So using the same values of mean, which is 1.98 liters, standard deviation of 0.03 liters. This time, we're looking for values that are less than 1.9. So but greater than 2.06. So we're actually interested in a region outside those boundaries, right? So the lower limit or the lower value is 1.9, while the higher one is 2.06. And let me just enter that for us. And then we press enter to recalculate. Notice that the regions that are shaded in the illustration are those in the left and the right tails. And these two regions together cover a total area of 0.0077. So what this means is that 0.77% of the bottles that are produced by the factory are either contain less than 1.9 liters of soda or greater than 2.06 liters. So the question of how many of the 5,000 will have to be discarded would be based on this value. So when you multiply 70.77% for this area to the 5,000, you should be able to get around 38.5. So that's approximately 39 bottles, which means that given these conditions, around 39 bottles will have to be discarded because they do not fit into the standards that the factory set for its production. So this is where you'd notice that the idea or an understanding of areas under the normal curve, normal distribution, standard normal distributions are going to be very important in making decisions about certain trends that we see in distributions, especially if those distributions are normal. Okay, so we will end the video here, and in the next video, I will show you how we can make use of Microsoft Excel this time to find certain areas under the normal curve.